Welcome to this breaking brief. We've just got this information in, and we are taking an urgent, granular look at a split-second event that literally happens millions of times a day across the web. Honestly, it usually goes entirely unnoticed. But with the massive scale of automated botnets and zero-day threats constantly hammering servers right now, we are zeroing in on the digital checkpoint protocol. It's that microscopic, high-security window of time between you requesting access to a platform and actually getting in. We've just received the step-by-step sequence of this rapid-fire security barrier, and we're going to break down the full anatomy of this digital handshake right now. Let's get right to it.
Okay, let's dive into this. Right at the gateway, before any connection is actually made or any data is even exchanged, you're hit with this immediate holding pattern. Just a moment. It's just 3 simple words, right? But they act as a massive, unyielding digital stop sign. You aren't rejected, but you certainly aren't accepted yet either. You're placed into a sudden state of suspense. The system is essentially freezing you right at the front door. And instead of just a vague pause, what we're actually seeing here is the system actively evaluating your IP reputation. It's cross-referencing your connection against known global threat databases and deeply analyzing your request headers, all before you're allowed to take even one single step forward.
And this brilliantly illustrates the timeline of what is actually happening during that tiny fraction of a second. What feels like a simple, maybe slightly annoying pause to us is actually a highly structured 3-step sequence of rapid-fire events. In second 1, we have the pause itself, locking down your progress and holding you in place. Then in second 2, rather than some invisible force just working magic, the system is actively executing rapid threat intelligence evaluations and deploying advanced client-side heuristics. Finally, in second 3, we see the final handoff to the actual system you're trying to reach. It's really a beautifully orchestrated microscopic ballet of security protocols happening literally faster than you can even blink.
Now, we can report a confirmed breaking development in this sequence. Verification successful. This is the absolutely critical security check phase of the connection, and the intelligence tells us that it has been officially cleared. At this exact microsecond in the timeline, the system's frontline defensive algorithms have scanned the incoming request. Passing this test usually means your browser just successfully solved a silent mathematical challenge in the background. Basically, it proved that your device's processing power and behavior align with a real live human user rather than some scripted headless bot. The initial heavy lifting threat assessment is totally complete, and you've passed the test.
Now, what's really interesting here is the sudden shift in status and power. You've done your part, right? Your verification was deemed successful, but immediately you're thrown into a brand new active holding pattern that is entirely dependent on the destination system. The baton has basically been passed. The readout updates to waiting for OpenAI.com to respond. And this is a critical moment of vulnerability in the connection sequence. The security gates are unlocked, but the host server still needs to actively wake up, open the door, and pull you inside to complete the loop. And it's crucial to understand here, this delay isn't just normal network lag. It's heavily tied to load balancing and rate limiting. The system is intentionally throttling the influx of authenticated requests so the host server doesn't just get completely overwhelmed. Let's see how this builds, because just when you think you're totally in the clear, the system issues its final, uncompromising demands. To proceed past this checkpoint and actually use the site, there are mandatory technical directives that your browser absolutely must execute. Step 1, enable JavaScript. Step 2, enable cookies. And make no mistake, these are not polite suggestions. They are the absolute hard-coded prerequisites for continuing. But why? Well, JavaScript is strictly required to compute those vital browser fingerprinting equations locally. And cookies, they basically act as the secure clearance token to ensure you aren't ruthlessly interrogated on every single subsequent click. Without these tools functioning properly on your end, the whole connection process just instantly aborts. So, the crucial point is that successfully completing this digital handshake relies entirely on a strictly synchronous protocol. Every single one of these conditions must be met simultaneously. You need the initial pause to trigger the sequence, you need the successful verification to clear the security net, you need the destination server to actually be awake, load balanced, and responding, and crucially, you literally must have JavaScript and cookies actively functioning on your own device to maintain that authenticated state. Think of it like a highly engineered chain. If even one single link breaks, the whole checkpoint fails and access is immediately denied. No way around it. As we wrap up this breaking brief, it's really vital to look ahead at what this means for the broader ecosystem. These rapid-fire security checkpoints are absolutely no longer the exception. They're the unavoidable standard across the web, quietly keeping out the malicious noise while letting authentic users like us through. But as we've seen, they require your browser to be a highly active, compliant participant.
So I want to leave you with this direct, critical question. As these invisible checkpoints become increasingly rigorous to combat AI-driven botnets, at what point does maximum security begin to permanently fracture web accessibility? Think about it. Thanks for tuning in to this rapid-fire breakdown, and keep your systems ready.